So we need to learn how to do something. And ladies and gentlemen, I am very careful when I say this. Please do not jump up out of your chairs. We are going to learn some math today. We are going to talk about some Pennsylvania standards that involve math in a way that will help you in the real world. Geometry. Geometry is our visual language of mathematics. We're going to use a technique and a formula called the Cartesian Plane. The Cartesian Plane is a formula that measures the x and the y axis from its origin to describe the size of a shape. Why do you think you would ever need to put numeracy, which would be numbers or dimensions, on work that you've done in the real world? Forget class.
3D printing.
Elaborate. It's a good answer, though. Hey, think about it. When we talk about 3D printing, we are talking about dimension. We are talking about an x and a y axis and an origin. As graphic artists, you're going to have to team up with people who are actually physically doing the work. One more time. Let's see if I can get another answer. What do you think, Maddie?
If you're designing like a product or a house or something like this.
Absolutely. It's pretty straightforward. It is pretty straightforward. Anytime you're designing a product or a service, it's going to require physical dimensions that have to be tangible, written down, so the product can be produced or the service can be executed. We have what we call vanishing point perspective, which I know you've heard a million times and you do all day long. But we also have this term axonometric perspective. Does anybody know anything about either one of those that they could share before I elaborate? Gerald, what do you think?
The vanishing point perspective, wasn't that the one that's like supposed to be 3 dimensions, like it goes?
I think you're saying it all correct, just a little. Vanishing point does start with a point in space. Everything works from that point, the vanishing point. Yes, Maddie?
I'm not sure, but axonometric probably means it works with some axis.
Very good answer. That's even deeper than I thought into it myself. I'm going to start with a dot in space. Now, you also sometimes set this when you begin this drawing, and I'll help you understand it by drawing this on it.
Horizon.
There we go. A horizon line. Very good. Thank you. Here's our starting point. There's our cube in space. The angles are very extreme. Well, you'll know. Why is this dimension, this is a cube, by the way, a perfect cube. This dimension is 2 inches. This dimension at the rear of the cube is now 1 inch. Wait a second. What's the problem?
Without writing how big it is, you won't be able to know because it gets smaller as it goes away, or it's further away.
Yes, 100%. So you cannot use vanishing point perspective in real world drawing, real world specifications. Remember that word, specifications. 2 inches and 1 inches means it's not a cube. It means it's a trapezoid. It's not right. So the layman being the worker, the installer, the co-worker, whoever's helping you is going to design and build the installation incorrectly. Now, in order to create true dimension so we can provide real specifications, we're going to switch our mentality. and not use a vanishing point, but use an axis, as Maddie said. So when we draw a cube in axonometric space, we're going to pick an angle. Inches is 2 inches, is 2 inches, is 2 inches. You could actually record these dimensions and specifications right on the drawing, and they won't look wrong. They will look right, they will be accurate, and effective. A trade-educated electrician has gone through schooling, at least 2 years of schooling in trade, maybe further education. They become a master electrician. They're sophisticated individuals. But they're not going to want to see a vanishing point perspective. It's not going to make any sense. They're not educated in that. They're educated in reading mechanical drawings, which are done in axonometric perspective. I love learning on the blackboard. I love drawing. I like getting perspective and drawing things up there, having you guys come up and do that. But we all feel more comfortable seeing pictures. Pretend with me that the art museum has contacted you and has asked you for a specifications sheet requiring the dimensional layout of your next art exhibit. That's what you're going to do. You need to put dimensions on paper. You can't send them a sketch because it doesn't tell them the math. Now, before we move on to the Cartesian plane, we're going to talk about that axonometric one more time. I've got good pictures I can show you. These types of drawings are used for accuracy in dimension and for mechanical drawing. What can we do with a ruler? Emma, what do you think? Right, you can measure because they're the same size. So you can, what is the Cartesian plane?
A grid?
It is a grid, yes. That grid has something very specific on it. Something that we talk about in Illustrator all the time. The X and Y axis. Right. What we're going to do is pretend that we've been contacted by the art museum to create an installation. So you have to send a specification sheet to the Philadelphia Art Museum determining the size of your art and the dimensions of it in vanishing point perspective. They know the actual artwork size. They're holding it. Say it's a 2 foot by 2 foot square. They know that. What they need to know is the distance between the pictures. And they can't determine that. You have to determine that. You're going to watch the video provided showing me doing the exercise. So you have a guide. You also have option 2 room. Here's the included video showing what happens as you lay out the Cartesian grid on the file. I'm giving you a transparent grid. The video shows you how to do it. We are going to walk through it one time so you can see. 1 through 7 are the instructions of what that needs to be done on the assignment. Here is your specifications sheet. All you're doing is starting from the foreground, recording the original size of the image, and you will then record the size of the middle image, midground image, and then the background image. 3 pieces required. You can do more. That's on you. As always, our workflow chart. So you are tracking and making sure you're following this assignment accurately. We are working with task 508, which is under Duty 500, digital imaging. This is an intermediate level function of using Photoshop, a raster image program. But we're using math. All right. And last but not least, your checkpoint. Check it off as you go so you know you're not missing any details. And there you go, guys. And then we're going to go back to our seats and perform the exercise. Thank you very much.